like this. There's two of them. If you're watching this online, then there's four sheets. You're going to cut them in half and in half again to make four um, corners or four squares. So cut them in half so that you have this. As we go through today's lesson, I'm going to show you each slide, and then you're going to use your notebook, your textbook, and your brain to come up with the answers for each blank in each slide. You have your word bank that looks like this. If you look at this here, you should know that this means distance divided by time. Then you have all of the words that you'll be using going all the way down. Here, this is all one. Final velocity minus initial velocity divided by time. Put your final velocity and your initial velocity in parentheses because it does follow the PEMDAS rule, meaning you would have to subtract the initial velocity from the final velocity and then divide your answer by time. Your word bank does not include these two words, so include them on there, rest and motion. These are all of the words or equations that you will use for each slide. Now, some may be used more than once, which means that if you use force once, it could be used again, so don't cross it off of your word bank. This means M times A means mass times velocity. So let's get started. I'm going to move fairly quickly for the video, but if you're watching the video, then you will need to pause it and then continue going. So the first one, define motion. Pause the video, use your book, your textbook, in your brain. Motion is the action or process of moving or being moved. Describe speed and velocity. Now you want to make sure that your answers make sense. Speed is the rate of motion, and it's the measurement of distance traveled over time. Velocity is the measurement of speed or rate and direction of motion. Velocity equals distance divided by time. What are two ways that you can change your velocity? Now think about what you know velocity to be. You can change your speed and change your direction. That will change your velocity or change your direction. Describe acceleration. Think about a plane taking off. Acceleration is the rate at which an object's velocity or speed, those are the same, kind of the same thing, changes with time. The equation is final velocity minus initial velocity divided by time. Here, this is not on your word bank. You'll use these phrases here to fill in these areas. So this graph is distance over time. So over time, distance increases, then levels off, and then distance decreases. You need to use these phrases to label these blue areas. Over time, this is driving away from A. Now, if you're sitting at a certain spot, or you went to see someone, or you're not moving, and then distance declining, going back to A, so returning to A over time. This graph is kind of similar, but this time it's a velocity and time graph. So instead of this being distance, this is now velocity, and this is time, and you're using these phrases to fill in the blanks. And you should have, this is accelerating because velocity is increasing, so that's accelerating. It's a constant velocity. This is your plane taking off. Now you're flying. And after landing, you're decelerating. Your velocity is decreasing. Describe force. Force is a blank or blank, and the equation. You should be saying force is a push or pull, and it's mass times acceleration. Now, a group of students split up into two groups of four for a tug of war. Each group pulls on one end of a heavy rope. Here you're going to draw a diagram showing what happens when the forces on the rope are balanced. The forces involved should be represented by arrows, and any motion should be drawn and labeled. Your diagram should include the students pulling on the rope. So you're drawing the tug of war, showing balance forces. You're also going to show the motion and the arrows of the force. This is on your one page that says about the tug of war, and that's split in half. So make sure you're doing this on the correct side. And you should have come up with something like this. You have four individuals on each side. They're both pulling. Because it's balanced, there is no motion. It's equal. Same scenario, however, now it's an unbalanced force. The forces involved should also be represented by arrows, and any motion should be drawn and labeled. Your diagram should include the students pulling the rope. Here, someone is winning. And it should look like this. This side is winning, so they have more force. They're still pulling over here, but they don't have enough force to beat this side. So the motion is going to this side. Describe friction. Friction is the resistance to motion. It happens when objects are in contact. Your shoe contacts the ground. And because of the resistance, you're able to walk and not slide all over the place. Less resistance, more slipping, which means less contact. In what direction is the force of friction directed? Think about it. When you're moving forward, your foot is actually pushing backward. So therefore, the force of friction is directed the opposite to the direction of motion. A person jumps out of an airplane. At first, the person speeds up during the fall, but then the person falls at a constant velocity, known as terminal ending velocity or terminal velocity. Identify the force that explains why the person continues falling after jumping out of the airplane and falls at a constant rate. The person continues falling after jumping out the plane because of the force of gravity and falls at a constant rate because of air resistance. Air resistance is a force that will slow things down. It's a push. Describe the difference between weight and mass. Weight is because of the force of gravity's pull on an object. Mass is the amount of matter or stuff in an object. So, here on Earth, you have mass. And the reason why you have mass is because of the amount of stuff. Your brain, your heart, your bones, your blood, the water inside your body. Your weight is because of gravity's pull on you. So would your mass be the same if you left here and went to the moon? Well, yes, it would be, because you still have a brain, a heart, blood, water, everything that makes up your body. You still have matter. Would your weight be the same if you left Earth and went to the moon? Well, no, because gravity's pull is not as strong. There's no gravity on the moon. as opposed to on Earth, so your weight would be different. Explain inertia. An object in motion will remain in motion, and an object at rest will remain at rest unless acted upon by an outside force. You should also be able to tell me that this is Newton's first law. Describe work. Work is done when a force causes an object to move in the direction of the force. So only when an object is moved in that direction can you say that it's work. This concludes your lesson for today. Make sure you have your booklet complete and use it for a study tool.